outer jaws are useful to measure the size or diameter from external diameter. If we wanted to measure 2 units, we are supposed to have 2 units, but the reading is 3. Reading is 3 because it is already starting from a step ahead. Then how to rectify the reading? And which one you can see, the main scale is fixed, which one you can see, the yellow colored scale, it is the vernier scale. See, I'm moving it. Hey everyone, I hope you all are doing good and you are prepared for the actual exam. So the exam is very near and our preparation is going way too ahead. With positive hopes, I would like to give a finishing touch on the syllabus by taking the experimental skills topics too. So just for your kind information, it's been officially the first time that experimental physics has been added to the syllabus. But that's not true if I say that this is the first time that experimental skills questions are going to come in the exam. So till last year also there were so many questions which were coming from these topics, and during the teaching curriculum we have already guided you regarding those topics. For examples, you talk about the resonance tube experiment, we have definitely taught you in the topic of waves. Meter bridge we have discussed in the topic of current electricity. Similarly, different types of experiments which you would be looking in this session, capillarity and surface tension, related properties like that, in different chapters during the discussion we have already seen them. Okay, so the target of these interactions will be to get to know some other information which might be missed before, or else to just take a review with a lot of good and guess, or you can say the probable problems for the exam. So yes, we are going to discuss the topic, but at the same time we are going to do those type of problems which are highly probable for the upcoming exam. Okay, let's hope for the best. I'm starting with the very first experiment, that is the experiment number 1 according to the syllabus, that is vernier calipers. So the experiment is to measure the length, measure the external diameter, measure the internal diameter, and measuring the depth of a container by using vernier caliper. So I just mentioned 3 applications of vernier calipers. Application number 1, measuring the external diameter. Application number 2, measuring the internal diameter, and yes, application number 3, that is measuring the depth. So we will see how it works. But before that, we need to understand that what is so special regarding vernier caliper. Why we have to study the vernier caliper, sir? So first of all, the thing which we need to focus on is how to calculate the least count, but standard vernier caliper. I'll talk about the least count first. Least count means the smallest measurement. We understand that is the smallest measurement that can be taken by an instrument. Smallest measurement that an instrument can read. So that can be taken by an instrument. Everyone understands this? Now, if we talk about a ruler, geometry box ruler, the ruler which you use in your day-to-day life, that ruler has the smallest measurement as 1 mm. Example, if we talk about the least count of a ruler, geometry box ruler, its least count, the smallest measurement that can be taken from that is 1 mm or 10 to the power minus 3 meters. So what if we want to measure a smaller length than this, sir? If we want to measure a dimension whose if you want to measure a physical quantity whose size is less than 1 mm, then definitely geometry box ruler is not a good idea. We will be using those devices which are having better resolution, which can measure the quantities up to much smaller scale. For example, if you want to measure normal currents, we make use of ammeter. But yes, if we want to measure the very small amount of current, in fact, precisely less than milliamperes also, then ammeter is not going to be a very good choice. Galvanometer is going to be a better choice because the least count of normal ammeter is 1 milliampere, whereas if we talk about galvanometer, the least count of a galvanometer is 1 microamperes, which means below milliamperes, the galvanometer is not going to, the ammeter is not going to show any reading, and hence we will be needing galvanometer. Similarly, if we want to measure smaller than this, we will say least count of vernier calipers. Least count of vernier calipers is going to be 0.1 mm. 0.1 mm, or you can say 10 to the power minus 4 meter. So that is our discussion, that we will talk about the vernier caliper. Generally, that's a standard vernier caliper. Standard vernier caliper. And if I talk about a standard screw gauge, that will be our next experiment. So least count of a screw gauge is much more smaller, which means if we want to measure even the smaller lengths than 0.1 mm or 1/10 of the part of mm, then we will be needing screw gauge, commonly known as micrometer. It can measure up to 0.01 mm or 1/100th of a millimeter also, or you can say 10 to the power minus 5 meters. 10 to the power minus 5 meters. So this is the reason that this is so special. This is a special reason why we want to talk about the vernier calipers. That if we want to measure the length less than 1 mm, then definitely our choice will be a vernier caliper rather than using a geometry box ruler. Alright. So now let us focus on the thing that how to calculate the least count. Before showing you how a vernier caliper looks like, before telling you how the vernier calipers behave, how to operate the vernier caliper, I am going to take up the more expected model of the Neet, that is how to calculate the least count. So I will say least count of vernier caliper. So basically there are two scales on a vernier caliper. I'll show you in a while and you will be enjoying that. Okay, let me give you a look. To maintain your excitement, let me give you let me take you for this one. So this is a basic vernier calipers which you can see in front of you. This blue is a box or a block whose size I want to measure. I want to measure its size, so I'm going to, just a minute, I think it's logged. So this is how a vernier caliper looks like. You can see that there is a structure. One by one I'm going to tell you, I'm going to brief you about everything. Imagine that you are holding this structure in your hands. So there is a gray scale that is called the main scale, and that is generally similar to the geometry box scale. Why I'm saying that that is generally symmetrical, similar to the geometry box scale, because the divisions which you can see right now, each division will correspond to 1 mm. I repeat, each division on the main scale generally corresponds to 1 mm, which is same as that of your geometry box ruler. When you can see the main scale is fixed, which one you can see the yellow colored scale, it is the vernier scale. See, I'm moving it. I can hold it, and by keeping my thumb on this gear type structure, I can easily rotate that and the vernier scale can translate. This is the yellow colored scale, vernier scale. This is blue colored box or block whose size is to be measured. So I can keep it here and I can increase or decrease its size, okay? And by making the jaws closing this object within, I can measure the size. So you can see a yellow color strip on the right bottom corner of the screen. That is going to give you the reading. I will explain it to you in a while, that how to take the reading and everything. But briefly, what I can say is, if you fit an object in between these jaws, these are called external jaws. These are called outer jaws or external jaws. Outer jaws are useful to measure the size or diameter from exterior, external diameter. If you see the upper structure, if it is movable, you can imagine that there is a hollow container in the inner region to which I am keeping these jaws. They will try to support it from inside. So the upper jaws are also called those jaws which measure the inner diameter. The lower jaws are going to measure the external diameter as per the diagram. The upper jaws are going to measure the internal diameter. And if you see, I'll show you. There is a structure at the end, the yellow colored structure. It is also a structure attached to the vernier scale. So how much do you move the vernier scale? Accordingly, that pin type body, that pin type structure, you can see that's moving. Which means how much we move the vernier scale, that length will go deep inside a container or a cap or the cap of your pen, and hence that is responsible to measure the depth. Right? So by this portion attached to the vernier scale, I'm not labeling them right now. I will explain them one by one. This portion is responsible to measure the depth. The lower jaws right now are responsible to capture or hold the body from outside, means external diameter, and the upper one will hold it from the internal, so which means that is used to measure the internal diameter. Hence, we can think that vernier caliper can be used for three purposes: measuring the external diameter, measuring the internal diameter, and measuring the depth. Alright, now let us come back. So this is a very important model for the Neet, and that's very simple. That's pretty simple. We will see. Least count of vernier caliper is given by the least count of main scale minus least count of vernier scale, or that can be written as 1 main scale division minus 1 vernier scale division. So basically the least count of vernier calipers is equal to the difference between the least count of main scale and vernier scale, or you can say the difference between 1 main scale division and 1 vernier scale division. That's the standard formula. And that is easy and important. Okay. We will see some examples. Example number 1. Let me take the example of standard vernier caliper. Now, what information do we have, sir? What information do we have regarding the standard vernier caliper? It says 1 main scale division, just like your geometry box ruler. 1 main scale division is equal to 1 mm, and n minus 1 main scale division coincides with n vernier scale division. Generally, vernier scale division are smaller, so the number of vernier scale divisions which can come in some range of main scale divisions, the number of vernier scale division will be larger and number of main scale division will be smaller, because the size of main scale division is larger and the size of main scale vernier scale division is smaller. So this is the information. This much is the information, and they are telling you determine the least count of vernier calipers. So I would say, okay, the way how to define, how you can derive it here, you can say we know here that least count of vernier calipers is equal to 1 main scale division minus 1 vernier scale division, but the problem is that we don't have the idea of vernier scale division, we have only main scale 1 mm. So let us substitute 1 MSD minus 1 VSD by unitary method can be substituted as n minus 1 by n MSD. See, n VSD is equal to this, so 1 VSD can be substituted as n minus 1 by n MSD. So from here, if you take the LCM, you are going to get n minus plus 1, which means 1 by n main scale division. That means, and you don't have to stop here. People generally do another mistake in this model, that they stop at the division. Remember, don't stop at the division, you have to stop at the measurement. You don't have to stop at the division, you have to stop at the measurement. What does that mean? Don't stop here, put the value of MSD. So 1 main scale division will correspond to 1 mm. And what other information are, what is that given to you? Basically, in a standard vernier caliper, 9 main scale division will correspond to 10 vernier scale division. So if 9 main scale division correspond to 10 vernier scale division, naturally you can see here that it is going to be 9 by 10. It is going to be 9 by 10. So it will be 1 by 10. I'll also talk in terms of n, don't worry. But as of now, I'm taking the geometry box ruler as a main scale and I'm saying standard vernier caliper. So that is 1 by 10 mm. And that's how you get it as 0.1 mm. 0.1 mm. Okay. Another example, I can take it for you. Example 2. I hope that's clear to you. Make it a habit the way you do it. Example 2. Say the way I was taking n VSD will correspond to n minus 1 MSD and 1 MSD stands for 1 mm. Then here I will say, see how I am going to deal with it. I will say the least count of vernier calipers. Again, the rule is it is 1 MSD minus 1 VSD. 1 MSD minus 1 VSD. The information is regarding MSD is given to you. So better to substitute VSD. So you will say 1 MSD minus 1 VSD can be substituted as n minus 1 by n MSD. If you take the LCM and simplify it, n minus n, again that's gonna be 1 by n MSD. Remember, I was doing the same here, but then I took exact data 9 and 10. So that's how you got the standard vernier caliper. But otherwise, you can put it here and you can get the answer in terms of n. 1 MSD is 1 mm, and hence the final answer is 1 by n mm. 1 by n mm. Let me take another example for you. Shift it here. All right, I think the size is already visible for you. So let me a bit minimize it. Now what I'm saying is, I want you to look at one more example. Example 3. Example 3. Let me modify the statement. Again, I'm giving you another data. Then we are going to see a lot of problems also. Example 3, I will say 1 VSD. 1 VSD is equal to 0.5 mm and 10 MSD stands for, or 10 MSD stands for, say 11 VSD, like that. 11 VSD, that's data, that's the data that is given to you. So what you do here, you will say how to do that. Least count of vernier caliper, again that is given as the difference between 1 MSD minus 1 VSD. All right. So now 1 MSD can be written as, see, now what you need to understand, in the previous two example, MSD information was given to you. So you substituted VSD into MSD, VSD into MSD, because main scale division is given to you. But in this particular example, if you notice, I have modified and I have said that one vernier scale division is correspond to something. So if vernier scale division is corresponding to something, so definitely the main scale division, we have to substitute in terms of vernier scale division. So main scale division can be 11 by 10 vernier scale division minus 1 vernier scale division. If you see that carefully, 11 by 10 minus 1 is 1 by 10 VSD, that is 1 by 10 of 0.5 mm, and hence the final answer will be 0.05 mm. Obviously that's not a standard vernier caliper, that is just an example that sometimes they give you the MSD separately, VSD separately. Remember two rules. Rule number 1, never stop at division, sir. Your final answer must be in terms of measurement. Okay. Rule number 2, substitute the other one in terms of known one. Example number 1, standard vernier caliper, main scale division was known, so you substituted the vernier scale into the main scale. Example number 2, main scale division is known, so again you substituted vernier scale into the main scale. But if you see the example number 3, in which vernier scale division is given to you, so you are supposed to substitute main scale division into the vernier scale. What is the second rule? Obviously substitute the unknown into the known one. I hope the logic is clear to you. Notes will be availed to you later on. So as of now, you can just see that, have a look. Take a minute, review everything, whatever we have talked about, the least count, why do we study the vernier calipers, and what are the basic examples regarding the vernier caliper. Then we will be, our next phase will be to understand how the vernier caliper works. I'll show you that once again. Then we will see how to take the reading. And that's it. After that, we will do some good number of problems, highly probable for the upcoming exam. See that once. Yeah, I hope you have reviewed it thoroughly. You have had a look. Now let me take you to another phase of discussion, that is how to take the reading. And during the discussion of how to take the reading, we have to talk about the types of zero error. So I will write the formula first for you. Reading, say diameter. Suppose you are reading the diameter, external diameter, internal diameter, depth. Suppose you are reading a diameter. The reading can be taken as MSR, main scale reading, plus least count of vernier caliper, which you have learned how to calculate, into vernier scale reading, VSR, minus zero error, or you can say plus zero correction, minus zero error or plus zero correction. I'll write them one by one for you. First of all, this is the main scale reading. Main scale reading is that division on main scale. Main scale reading is that division of main scale which is left to the zero of vernier scale, which lies left to the zero of vernier scale, or you can also call it VSZ. VSZ stands for vernier scale zero. I'm going to use a lot of abbreviation, short term. Please try to understand. Okay, vernier scale zero. Okay, that's what the first thing is. That is main scale reading. Try to keep it in mind. I'm going to show you that very soon. Next is diagrammatically, we will understand it better. You will definitely feel as if you are having the vernier caliper in your hands and you are operating it. So least count, we have already seen how to determine the least count of vernier calipers. That is in front of us. Few examples we have taken. Now vernier scale reading. Is VSR is vernier scale reading. Vernier scale reading is that division of vernier scale. That division of vernier scale that coincides with any division of main scale. So which division of vernier scale coincides, that matters to us, but that coincides with which division of main scale, that doesn't concern us. I said that with any division of main scale. I repeat, we have to count that which division of vernier scale is coinciding with any division of the main scale. What is which division of the main scale doesn't matter to us. Which division of vernier scale matter to us. We will see that. Now, if you notice, the third term is zero error or zero correction. That comes into the picture when your device is faulty, when you are not dealing with an appropriate vernier caliper, when you are not dealing with an accurate instrument. Okay, not highly calibrated instrument. Fine. So basically what you can conclude here is, sir, zero error is to be algebraically subtracted and zero correction is to be algebraically added. So I will show you what type of zero error will come into the picture and why it comes. So what we have understood is main scale is ultimately a fixed scale and vernier scale we have to take it a movable scale. So let's see what are the types of zero error that will come into the picture. If our main scale which is the fixed scale is like this, that this is 0, you can also call it MSZ, main scale 0. This is MSZ, main scale 0. And if my vernier scale, which is my movable scale, is like this, that it's 0 coincides exactly from here. And you are going to move it like this. Okay. So suppose if there is no object between the jaws, any jaws of vernier caliper, and you start the race from the beginning and both the zeros are already coinciding, which simply means there is no error, because if you move 10 divisions, if you are moving 10 divisions, then definitely you will say the readable value, the red value and the traveled value, both are going to be same. How much you travel, that much you read. How much you travel, that much you read. So there is no zero error. This situation will correspond to no zero error. No zero error, and hence there will be no zero correction. No zero correction. Let me take you to another stage. Another stage is that this is the main scale, and that's my main scale 0, and this is the vernier scale. And when there is no object between the jaws, no object between the jaws of the vernier caliper, the 0 of the vernier scale is already ahead and it is supposed to move like this. If the 0 of the vernier scale is already ahead and it is supposed to move like this, then can I say it is already ahead? If it is already ahead, it will travel less but reading more. It is measuring less, traveling less. Even if it travels 2 steps, it might show you 3 steps or 4 steps because it was already leading. So you will say travel less but reading more. Reading more. If it is traveling less but reading more, reading is more. Whatever it has to give, it is sending, it is giving you somewhat more than that. So how to correct it? Sir, correction will be definitely negative. How to correct it? We wanted to measure 2 units. We are supposed to have 2 units, but the reading is 3. Reading is 3 because it is already starting from a step ahead. Then how to rectify the reading? Obviously, if it is reading ahead far much beyond than that, then it has to be subtracted. So you will say 0 correction. How to correct it? 0 correction has to be negative and 0 error has to be positive. 0 error has to be positive. That's what you call it, the positive 0 error. That's what you call it, a positive 0 error. Okay. Let me give you another example. You will be able to compare and then we can talk. I'm saying next time, this is again my main scale and this is the main scale 0. Suppose this is the main scale 0 and I'm saying that this time the vernier scale, 0, when there is no object between the jaws of vernier caliper, the vernier scale 0 is a bit left of the main scale 0. If the vernier scale 0 is a bit left of the main scale 0 and it moves like this, so definitely here what's going to happen? You will say it will be traveling more because it is lagging. This time it is not leading. Earlier it used to lead. This time it is lagging. So it is traveling more but reading less. So whatever it wanted to measure, the actual measurement, whatever it wanted to measure, the reading is somewhat less than that. In comparison to actual measurement, if reading is somewhat less than that, so definitely how do you rectify? So something is less, the rectification requires some sort of addition. So 0 correction requires positive and naturally 0 error is coming out to be negative. 0 error will come out to be negative. I hope the logic is clear to you. Okay. So 0 correction is going to be positive and 0 error is going to be negative. So what you need to understand is 0 error has to be algebraically subtracted, whereas 0 correction has to be algebraically added, and both are negative of each other. Okay. So don't remember left, right, don't remember positive, negative, 0 error. What you remember is traveling and reading equal, no correction required. If it is already leading, it will travel less, but reading will be more. So correction has to be subtracted, negative. Correction has to be negative. Naturally, 0 error will be positive because of opposite nature, opposite sign. When it is starting from somewhat lagging, then it has to travel more, but given reading will be automatically less. How to rectify? Because it has already traveled more, it should give you more, but by default giving less. So correct it by adding something and naturally 0 error will be negative. So another way of remembering and relating it is, if you are starting from the right, error is positive. If you are starting from the left, negative sides, the error will be negative. 0 error is priority. According to that, we can talk about the 0 correction also. I hope the entire logic is clear to you. You have got the idea. So before we emphasize much on it, first of all, let me show you with MSR, LS and that. Let us read it once again together. MSR stands for main scale reading. That division of main scale which lies left to the 0 of vernier scale. So we have to move the vernier scale and we have to identify where is the 0 of the vernier scale. to that 0 of the vernier scale, just see which main scale division is just left, just has crossed. Okay, that is main scale reading, MSR. Now what about the VSR, sir? Vernier scale reading. Vernier scale reading is that division of vernier scale which coincides with any division of main scale. Which exact division of main scale? Doesn't matter to us. Main scale division doesn't matter to us. Is that okay? Hope you got the idea. Okay, that's how you take the reading, that's how you correct the reading, and that is what the taking reading thing. How to take the reading, how to read a vernier calipers. Okay, let's see. Now, so first of all, I'll try to remove this and I will show 0, 0. So when there is no object between the jaws, between the vernier caliper, yellow scale, and the main scale, vernier scale and main scale. So when there is no object between the jaws of vernier caliper, see both the zeros are coinciding. 0 of the main scale, basically main scale reading. Entire discussion, main scale reading will be given by the blue cursor you can see, and vernier scale reading into least count, the second term. Vernier scale reading into least count, the second term, is going to give you, is going to be given by dotted red line. First term will be given by blue line, second term will be given by dotted red line, okay. So now both the jaws are connected, and if you want to see that, there will be no pin which is outside. A pin can come outside, but right now there is no pin outside. Okay, so everything is 0, 0, 0. Fine, everything is 0, 0, 0 here. All right. Now let us take the object, sir. So I will insert the object here, and before reading the size of the object, I will try to tight it. I'll try to close it. Okay. Now the moment I close it, you see vernier caliper 0 is here. You can see, I think I'll a bit zoom in to this. Oh, yeah. So for your better observation, you see the 0 of the vernier scale, okay. Which reading of the main scale is just left to the 0 of the vernier scale? I repeat, which reading of the main scale, gray scale, is just left to the 0 of the vernier scale? That is highlighted by blue color. See, that is highlighted by blue color. That is 5 mm centimeters, that is 0.5 centimeter. See the yellow strip at the right bottom corner. The yellow strip at the right bottom corner is giving you a reading. What is the diameter or size which you are reading? And the units you can see, that is in centimeters. So this is basically 0.5 centimeters. 5 mm like your geometry box ruler, in centimeter that's 0.5 centimeters. All right, we got that. Now the second thing is, what is the least count? Least count of vernier caliper is 0.1 mm or 0.01 centimeters. 0.1 mm or 0.01 centimeters, that's the standard vernier caliper. Now see here, vernier scale division. You need to identify which division of vernier scale coincides with any division of main scale. I repeat, coincides with any division of main scale. What exact division of main scale? That doesn't matter to us. Just focus on the vernier scale. So 0, 1, 2, 3, 4, if you count the total, the 8th will be that division which is in most of the alignment with any main scale division. See, the main scale division is 1, this is 10 basically, 10 mm, 11 mm, 12 mm, 13 mm. 13 mm which is coinciding with 8th division. But this 13 doesn't matter to us. What we are interested in, that vernier scale division that coincides with any main scale division. I hope you got the idea. So main scale reading is 5 mm or in centimeters 0.5 plus there will be VSR 8 into least count 0.01. VSR 8, I'll show you the second term. It is VSR 8th division of vernier scale coincides with any division of main scale into least count of vernier caliper, that is 0.01. So what you can see is 8 into 0.01, that's 0.08. 0.08 minus 0 error. But there was no 0 error. How do you know that, sir? Because if there is no object, between the jaws of vernier caliper, both the zeros are coinciding. If both the zeros are coinciding, you will have no zero error, no zero correction. I'll show you one more thing. Suppose no sir, we want to see a positive error. I hope you remember positive zero error means you are traveling from the positive leading side. So let me change it. Zero error. We have taken the zero error as no zero error to be 0. Let me take zero error as plus 5. If I take the zero error as plus 5, did you see that? Keep looking here. I will change it back to 0. I'm changing back to 0. Keep focus on 0 of vernier scale and 0 of main scale. Changing it. Keep looking there. See, if there is no zero error, then both the zeros are one-siding. And if there is a positive zero error, even if there is no object between the jaws, the zero of the vernier scale is already leading. If the zero of the vernier scale is already leading, it will travel less but reading more. If it is traveling less but reading more extra, then you have to subtract it in order to get the proper reading. So obviously you have to subtract it in order to get the proper reading. So let me change the size of the object. Changing the size of the object, then let us keep it here and I am closing it. Let us take the reading one more time. MSR, that reading of main scale which lies just left to the zero of vernier scale. So zero of the vernier scale left to the zero of vernier scale, that is 8 mm. And if you want the reading in centimeters, that has to be 0.8 centimeters. First term. Second term, least count of vernier calipers. Standard vernier caliper, least count is going to be 0.1 mm or 0.01 centimeter into VSR. That division of vernier scale that coincides with any division of main scale. Which division of main scale doesn't matter to us. Which division of vernier scale matters to us. So you count, there is 7th division of vernier scale that coincides with any main scale. So 7 into 0.01 centimeter, that's what your second term is, 0.07. And let us not forget, this time it was a faulty vernier calipers. So minus you have to do the zero error, since it was leading, traveling less, reading more, it has to be subtracted. That's why it is 0.82 centimeter after calculation coming. Okay. Now suppose we understood, sir, what is negative zero error, what is positive zero error, plus 5, positive zero error. Let me try to see what is negative zero error. Now you keep looking here. You keep looking at both the zeros. I'm going to change this. Keep looking at both the zeros. I'm going to change it to minus 8. So zero error I am changing to minus 8. Now could you see the zero of vernier scale has been shifted to the left, or else let us change it to minus 5. The zero of the vernier scale, easy to calculate hai. The zero of the vernier scale lies left to the zero of the main scale. That simply means that this time the scale will be moving ahead. The vernier scale will be traveling a lot, but reading will be relatively less. If traveling a lot, still reading less because it was lagging, it was behind, that simply means that this time you are supposed to add something. I repeat, you travel a lot, still reading less, how to rectify? Add something. If you are going to add, so see, zero error is negative, minus will automatically give you the positive. Minus will automatically give you positive. Alright, so if you want to take the reading now, you can just keep this object here. Now you can again try. What is MSR? That division of main scale that lies left to the zero of the vernier scale, that's gonna be 5 mm, or in centimeters 0.5 centimeter. What is the least count? 0.1 mm or 0.01 centimeters. What is VSR? That division of vernier scale that coincides with any division of the main scale. So this time the third one is coinciding. You are supposed to multiply the VSR3 with the least count 0.01. That's why you are getting 0.03. Minus the zero error, but zero error because of this faulty vernier caliper, it was minus. That's why minus will eventually give you plus. I hope you got the idea. Thank you so much for your patience and understanding that. Yes, now I hope the vernier caliper would have been quite clear to you. So what we have understood is easy process. more important and common for the exam and the easy for the exam, that is how to calculate the least count. Two rules. Rule number one, never stop at the measurement. Remember, you have to never stop at the division, you have to answer till the measurement. Rule number two, always substitute the unknown in the terms of known. In example 1 and 2, MSD was known, so you substituted VSD into main scale division. In example 3, Vernier scale division was known, so you substituted the main scale division into Vernier scale division, like that. Okay? And then how to take the reading? During the taking of reading, you need to take care of MSR as per the instruction, VSR least count as per the instruction. Zero error or zero correction will be depending upon did you start from zero reference or else either you are leading or lagging. Leading and lagging should be treated in order to compensate the behavior. If you are traveling less but reading more, you should be adding, compensation should be positive. And if you are traveling more and reading less, compensation should be negative. So I would say this term zero correction here, this is a sort of compensation. This term zero correction is a sort of compensation to the leading or lagging. Compensation to the leading or lagging. I hope that's clear to us. All right. So now we have understood what is vernier caliper and how we can treat that, okay, how we can operate it. Let me take you directly to the problems. Now we will discuss some problems which are easy, which are interesting, as well as which are important, which are predictable models. Okay, so whatever problems we discussed today, make sure that you do it this way, that even if that comes in the exam, you can still do it in partial sleep. Obviously, you are not sleepy in the exam, you don't have to, but still make sure that these problems are handy for you. So question number 1, the main scale of a vernier caliper has n divisions per centimeter. For one main scale division, I will say what they are saying is n main scale divisions is equivalent to 1 centimeters. Main scale of a vernier scale has n divisions per centimeter. So for each centimeter there are n divisions, or you can say 1 MSD corresponds to 1 by n centimeters. Now, of the n division of the vernier scale coincides with n minus 1 divisions of main scale. So they are saying n vernier scale division coincides with n minus 1 main scale division. And then they are asking you the least count of vernier calipers. So how do you calculate the least count of vernier caliper? Least count of vernier caliper will be equal to, 1 MSD minus 1 VSD, whose information is given to you, MSD, so you have to substitute the VSD into MSD. So that will be 1 main scale division minus 1 vernier scale division can be written as n minus 1 by n MSD. If you take the LCM, you got the answer as 1 by n MSD, 1 by n MSD, and that's why people directly say option 4, but that's wrong. What I have taught you, don't stop here. Don't stop at the division. You have to get your final answer in terms of measurement. How do you say that? You will say that, sir, that will be 1 by n. And now let us keep the value of main scale division. That's going to be 1 by n centimeters. So that will be equal to 1 by n square centimeters. 1 by n square centimeters. I hope the logic is clear to you. All right. So this way you can easily calculate the problem, and hence the correct option is not 4, correct option is not 4, correct option is option 1, 1 by n square centimeters. All right. Hope that's understood to you. You can take a look. Same rules. If you understand the lecture for the starting 10-15 minutes, definitely the entire session is going to be very easy and very obvious, because you have understood how to, take up the things. Now, talking about the next. Example 2. In a vernier caliper, one main scale division is x centimeters. In a vernier calipers, one main scale division is x centimeters. So, one main scale division is equal to x centimeters. and n division of the vernier scale coincides with n minus 1 division of the main scale. So n divisions of vernier scale division coincides with n minus 1 main scale division. But remember, we are having the idea of MSD. The least count in centimeters of the vernier caliper is, so how do you calculate that? You will say we have the idea of main scale division. So again, we have to substitute the vernier scale into main scale. So least count of vernier calipers is equal to least count of main scale minus least count of vernier scale, or you can write it as 1 main scale division minus 1 vernier scale division, that is 1 main scale division, since the idea of main scale is given to you. So you are supposed to substitute VSD into MSD, that is n minus 1 by n MSD. Again take the LCM, you got 1 by n MSD, don't stop here, that will be 1 by n, and 1 MSD corresponds to x centimeters, and hence the final answer is x by n centimeters. That's gonna be your result. I hope this much is clear to you. Alright, so depending upon different problem models, we have to follow the same steps, same rules, keeping few basic things into mind. Basic thing number 1, never stop at the measurement or at the extent of division, get the final answer in final measurement, centimeter, millimeter, like that. Number 2, always substitute the unknown into known. It is quite obvious, that's what we do. Okay, don't worry, the notes will be definitely availed to you, notes will be given to you. Right now you try to have the momentum, try to understand how to do. Okay. Next problem you can also try parallelly. Let us try in a quick mode. Okay. So what the question is saying, n divisions on the main scale of vernier calipers coincides with n plus 1 division of the vernier scale. So n main scale division coincides with n plus 1 vernier scale division. I told you vernier scale divisions are smaller in size, so greater in number. Main scale division are greater in size, so smaller in number. Okay. If each division of the main scale is equal to 1 unit, one main scale division is equal to 1 unit. If each division on the main scale is equal to 1 unit, so one main scale division is equal to 1 unit, determine the least count of the instrument. So you will say, how do you calculate the least count here? So least count of vernier calipers, again it will be 1 MSD minus 1 VSD this time, and you see that, you know this, that every option is talking about in terms of main scale division. So this time you don't have to answer in terms of meter, millimeter, centimeter, like that. You have to just answer in terms of main scale divisions. So that will be 1 MSD as it is, and that is minus of 1 VSD. 1 VSD can be substituted as n by n plus 1 MSD by unitary method. If you take the LCM, n plus 1 minus n, that's 1 by n plus 1 MSD, or that can be written as n plus 1 inverse main scale division. Okay, hope the logic is clear. 1 by n plus 1 means basically n plus 1 inverse main scale division, and hence the correct option is option C, n plus 1 inverse. Here it is n plus 1, n plus 1 inverse, and 1 minus n. I hope that's cool. Hai? Hope you understood quickly. Alright, can we move ahead? Next is, in an experiment, I'll just try to see that whether it is clear in fonts or not. I think that's okay, we can understand it here. If you want, I can even, yeah, I think now it's more visible. In an experiment, what's given to us? The angles are required to be measured using an instrument. This time you are not talking about the linear things, you are talking about the angular. 29 divisions of the main scale exactly coincides with 30 division of the vernier scale. 29 main scale division exactly coincides with 30 vernier scale division. The smallest division on the main scale is half a degree. One main scale division or least count of main scale. One main scale division or least count of main scale, that is given to the smallest division is half a degree. So 0.5 degrees or half of a degree. Okay, or that can also be written as basically 1 degree will correspond to 60 minutes. So half degree will correspond to 30 minutes. 30 minutes. I hope you know this. If not, then I would like to emphasize for you that 1 degree will correspond to 60 minutes and 1 minute will correspond to 60 seconds. So naturally 1 degree can also be written as 60 minutes into 60 seconds. So that will be 3600 seconds. Okay, 3600 seconds. So 1 minute is represented by 1 dash generally you can say, and it is 1 second is represented by 2 dash. It is just the way how do you write. Doesn't matter too much. Come back here. Now what they are asking is, they are asking to figure out the least count of the instrument. So here I will say least count of this vernier caliper will be equal to 1 MSD minus 1 VSD. Since we have the information of MSD, we are supposed to substitute VSD into MSD. So that's 1 main scale division minus 29 by 30 main scale division. Ultimately, it is equal to 1 by 30 after taking the LCM. 30 minus 29, that's 1 by 30 main scale division. Don't stop here. Keep the measurement. 1 by 30 of main scale division is basically 30 minutes. Main scale division is 30 minutes. If you subtract, the final answer is going to be 1 minute. 1 minute. Or that can also be written as 60 seconds. 60 seconds. Double dash. Okay. So 1 minute is your correct answer. So first option, I think. First option is your answer. 1 minute. Is it fine? So why I took this problem, because if you are dealing with vernier caliper, a general mentality is that if we are talking about vernier caliper, obviously we are going to deal with linear distance. No, that's not true. That problem model teaches you directly that even if the vernier caliper is used to measure the linear dimensions, length, breadth, height, like that, the angular dimensions can also be connected to some sort of problems. But be comfortable, you have to follow the same pattern. Okay, I hope that's okay with you. One general information was there in terms of angle. So another problem we can see. Okay, now another problem for us is, in an instrument there are 25 divisions on the vernier scale which coincides with 24th division of the main scale. So what is given to us? That 25 divisions on the vernier scale, 25 VSD vernier scale division coincides with 24 main scale division. So that is 24 main scale division, MSD. 1 centimeter on main scale is divided into 20 equal parts. 1 centimeter is 20 equal parts, 20 MSD. Or from here, 1 MSD main scale division will be equal to 1 by 20 centimeters. 1 by 20 centimeter means that is going to be 0.05 centimeters. 1 by 20, 1 by 2 means 0.5, 1 by 20 means 0.05 centimeter. Okay. Now what they are asking, the least count of the instrument. So again, they have modified the language in the middle. But now again, if they are asking you the least count of vernier calipers, least count of the instrument, least count of the vernier caliper, situation is the same. 1 MSD minus 1 VSD. You can also call it least count of main scale minus least count of vernier scale Anyways, the information we have is about the main scale division. So I will write it as 1 MSD minus 1 VSD can be written as 24 by 25 MSD. Yeah, by unitary method from the first step, 24 by 25 MSD. If you take the LCM, that's gonna be 25 minus 24 by 25 means 1 by 25 MSD. Or don't stop here, 1 by 25 main scale division is 0.05 centimeters. So if you divide it by 25, that means definitely it is going to be 0.002 centimeters. 0.002 centimeters, hence the correct option is option 1, option A, 0.002 centimeters. It's just the unitary method, basic formula and basic calculation. See that once carefully, then we will move ahead. All right. Hope that is also clear to you. Let me take you to another one, another problem model what we have. Example 6. So we have targeted the 10 problem models, 10 different examples today. 50% of the job is already done. I hope you have realized that understanding the vernier caliper at the start might take few minutes, but once you have a proper understanding, the reading of vernier calipers and determining the least count of vernier caliper is going to be very easy. Okay. So the vernier caliper of a traveling microscope has 50 divisions which coincides with 49 main scale division. 50 division that coincides with 49 main scale division. Traveling microscope and vernier scale. So 50 vernier scale division coincides with 49 main scale division. All right. Can increase the size a bit for your convenience. 50 vernier scale division coincides with 49 main scale division. They are saying if each main scale division is 0.5 mm, if each main scale division 1 MSD coincides with that is equal to 0.5 mm, calculate the minimum inaccuracy of the measurement of distance. Now you have to understand that here, what is the minimum inaccuracy? They can also ask you the resolution. The languages are same. Minimum inaccuracy. Minimum inaccuracy in measurement. Minimum accuracy in measurement or minimum inaccuracy in measurement or resolution or least count. They all means the same. They all mean the same. Okay. If they all mean the same, so how do you calculate that? So I will say further that least count he indirectly they are asking least count of vernier caliper, that is 1 MSD minus 1 VSD. 1 MSD, let me keep it that way as of now. 1 VSD can be substituted as 49 by 50 MSD. So if you just simplify that after taking the LCM, you got 1 by 50 MSD. Let us not stop here. That will be 1 by 50. Main scale division corresponds to 0.5 mm. Okay. So that will be equal to, if you divide the 0.5 by 5, answer will be 0.1. But since you are dividing it with 50, answer will be 0.01 mm or basically 10 to the power minus 5 meter. It has reached to the resolution of screw gauge, or you can say micrometer, screw gauge or micrometer. It has got that much of resolution, 10 to the power minus 5 meter. All right. So another problem model just to teach you what other languages can be used. So you need not to get worried about it. Okay. I hope that's clear. Now let us take another example, example 7. Now that's an interesting question, very interesting question. I'll increase its size a bit. So I think now it will be more comfortable and visible for you. Right. The vernier of a vernier scale is divided into 10 divisions which coincides with 9 division of the main scale. What are the information? So People feel, or you might be feeling, so that's a very big problem. How to do it in the exam? I say the small problems could be tricky problems. If the problem is big in size, which means indirectly it is telling you much more information. So it's just you have to keep collecting the information. It can be a descriptive problem, okay, giving you many things, but what they ask is generally very simple. So let us try to read it together and try to gather the information, what is given in it. The vernier of a vernier scale is divided into 10 divisions which coincide with 9 division of the main scale. So 10 vernier scale division is coinciding with 9 main scale division, each main scale division being 0.5 mm. So 1 MSD will be equal to 0.5 millimeters, 0.5 millimeters. When the two jaws of the instrument are in contact with each other, the fourth division of the vernier scale coincides with the main scale division, and the zero of the vernier scale lies to the right of the zero of the main scale. Means the zero of the vernier scale. I'll see another information what they are giving. They are saying when the two jaws of the instrument are in contact with each other, the fourth division of the vernier scale coincides with the main scale division, and the zero of the vernier scale lies to the right of the zero of the main scale. So if this is the main scale, that's the main scale 0. The zero of the vernier scale, lies right to the zero of the main scale. So it is 0 here and it is traveling like this. It is towards the right, right? So obviously since it is already ahead, here you have to see that it will be traveling. If it is already ahead, then you will say it will be traveling less but reading more. Traveling less but reading more. If it is reading more, than the required, then how to compensate it? Obviously you have to subtract. So compensation, 0 correction has to be negative and 0 error. Anyways, if it is starting from the positive side, so 0 error is going to be positive. 0 error is going to be positive. And how much, sir? If the 0 error is given, that's fine, take it. If that is not given, then you again have to take care of the least count. Least count is, you will find here, then you multiply it with the fourth division. I'll show you how. Now, the third phase is reading. So, you will say when a sphere is inserted between the jaws, the zero of the vernier scale lies slightly right to the 1.8 centimeter, and the sixth vernier scale division coincides with the main scale. They are asking you the diameter of the sphere. So let us do it one by one. Let me take this information here and I'll try to identify the least count first of all. Least count. So can I say here, least count of vernier caliper will be equal to 1 MSD minus 1 VSD. So 1 MSD is, that's fine. 1 VSD can be written as 9 by 10 MSD. So that is going to be 1 by 10 MSD, but that's not the end of the story. That's 1 by 10 of main scale division is 0.5 mm. So 0.5 mm by 10 karenge, so that will be 0.05 mm. But if you see the options carefully, all the options are in centimeter, centimeter, centimeter and centimeter. So that's gonna be 0.005 centimeters. Once again, main scale division is 0.5 mm. If you take the 1 by 10 of the main scale division, you will get 0.05 mm in terms of centimeter. That's 0.005 centimeters. All right. Now, so if they ask you the zero error also, so if they ask you the zero error is to be positive. The zero error is to be positive, and they say fourth division of the vernier scale. They say fourth division of the vernier scale coincides with a main scale division. Which main scale division? We don't even are interested in that. So zero error is also calculated. If the zero error is a given data, directly use it. If that is also given in the term of measurement, then you have to do the same thing. You have to do the same thing in the third term what you do in the second term. That is, division into least count. Here also it is number of division into least count. Similar thing I'm going to do here. So I will say division into least count. The least count is 0.005 centimeters. Into which division we got? Fourth division. So if you multiply that, you will get positive of 0.02 centimeters. 0.02 centimeters. Hope that is clear to you. Okay. Given details, talking about the zero error, calculating the least count, calculating the zero error. Now talking about the reading. Reading will be MSR, main scale reading, plus least count of vernier caliper into VSR minus zero error. Zero error. If zero error is given in terms of data, we will directly use it. If it is given in terms of division, then we have to see positive or negative and we have to calculate it separately. So main scale reading. How is the main scale reading? It says when a sphere is inserted between the jaws. I'm trying to understand this. When a sphere is I'll break the problem into part. When a sphere is inserted between the jaws, the zero of the vernier scale lies, this is the main scale, the zero of the vernier scale lies right to the 1.8 centimeter. So it lies right to the 1.8 centimeter. So obviously 1.8 centimeter, the zero is right. So main scale reading is that reading of main scale that lies left to the zero of vernier scale. So 0 lies right to it or that lies left to the 0 means the same thing. This is MSR, main scale reading. I repeat, 0 lies right to it or that lies left to the 0 means the same thing. So main scale reading here, what is the main scale reading? Main scale reading is 1.8 centimeters plus least count of vernier caliper. Least count of vernier caliper is 0.005 centimeters. Vernier scale reading, the vernier scale reading is how much given to you? Vernier scale reading is sixth division, sixth vernier scale division coincides. So that is into 6 minus positive of 0.02. Everything is in centimeters. So that's 1.8 plus 6, 5, 30. It's 0.03 minus 0.02. So that is 0.01 and hence it is 1.81 centimeters. 1.81 centimeters. That is going to be your final answer. I would suggest you take a minute, review everything. I have broken the question into two parts. First part is giving you the idea of the vernier, the least count, vernier scale division, main scale division and all, and as well as the zero error. The second half of the question is telling you the idea of the reading, how to take the reading. So that's how it's a big, good descriptive problem from the vernier caliper. Have a look, then we will move ahead. And remember, we have to do 10 different models, 10 problems to understand everything. And one problem directly from all these 10 you can directly expect in the final exam. 7 out of 10 are already done, so have some more patience. 3 more problems to go. I hope you are reviewing the problem in parts. That's what I'm waiting for. All right. Chaliye. Taking you towards the next problem. Example 8. The main scale of a vernier calipers read 10 mm. The main scale of the vernier calipers read 10 mm in 10 divisions of vernier scale coincides with 9 division of the main scale. So what are the information given to you? First of all, it's given that main scale of a vernier caliper reads 10 mm means 1 MSD main scale division, that is equal to 10 mm in 10 divisions. Okay. In 10 divisions of vernier scale coincides with 9 divisions of main scale. 10 divisions of vernier scale VSD coincides with 9 division of main scale 9 MSD. So from here definitely I can talk about the least count. From this information till here, I have broken the question here. Okay. Till here, I will say the information what I can get is least count of vernier caliper is equal to again 1 MSD minus 1 VSD. So you can write this as 1 MSD minus 1 VSD can be written as 9 by 10 MSD. So the final answer is 1 by 10 MSD. Don't stop here. That is 1 by 10. Main scale division reads 10 mm. So into 10 mm, and hence the answer will be 1 mm, but all the 4 options are in centimeters. So that should be 0.1 centimeters. 0.1 centimeters. So we got the data in terms of centimeters. Now they say when a cylinder is tightly placed between the two jaws, the zero of the vernier scale lies slightly left behind 3.2 centimeters. 3.2 centimeters. One more thing I would like to highlight here, that least count, or you can also write it as least count of main scale, that is equal to 10 mm. You can also write it as 1 centimeters. Where we will be using this, let's have a look carefully. Now the next line says when a cylinder is tightly placed, the zero of the vernier scale 0, that lies left behind 3.2 centimeters. That lies left behind. So if this is main scale, so this zero of the vernier scale is left behind 3.2 centimeter. For be careful guys, 3.2 centimeter is not left to the zero. The zero is left to the 3.2 centimeter. So don't consider it to be MSR. Now you need to think that least count of main scale or one main scale division corresponds to 1 centimeter. So if it is 3.2 centimeters, if it is 3.2 centimeters, I guess, how is this possible? I think there is a problem with this question. The reason is main scale, if it reads 10 mm, or basically if it reads 1 centimeter, if it reads 10 mm or 1 centimeter, then 3.2 centimeter cannot come as a reading. I repeat, if the main scale reads 10 mm or 1 centimeters, then 3.2 can never come. If 3.2 comes, which means 0.1 centimeter is readable and hence 1 mm is readable. I repeat, I would like to rectify this problem. I think the question is that here it is only 1 mm. If it is here only 1 mm, then definitely, now I will see, I will do some changes. 1 mm, so it can be written as 0.01 centimeter. I hope you got the idea why I am changing. I am changing this because if it reads, 0.1 centimeter, if it reads 0.1 centimeter, then only it's possible to give you a reading of 3.2. 3.2 matlab 1 decimal place, means least count should be 0.2 centimeters. So if you 0.1 centimeters, so if you check this 0.1 centimeter back to 3.2, then there must be some 3.1 centimeter, and this 3.1 centimeter here, should be treated as MSR, main scale reading. And definitely there is some correction required here also. So I'm going to do that. This is going to be 1 mm. This is going to be 1 by 10 of 1 mm. 1 by 10 of 1 mm means standard vernier caliper. 0.1 millimeter, or you can write it as 0.01 centimeters. So standard vernier caliper. That's the standard vernier calipers. That 9, you remember first example I gave you today, 9 MSD, 10 VSD, standard vernier caliper, like that. So that's what it is. Now, what we have to see here is, we got MSD and they are saying, and fourth vernier scale division. Focus on this. Fourth vernier scale division coincides with the main scale. The diameter of the cylinder is. So how to take the diameter? Now I will say here, reading. Reading is basically the reading of diameter only, of dia. That will be equal to, standard formula is MSR plus least count into VSR minus zero error. Nothing is given regarding the zero error. You can keep it 0. Nothing is given, so don't encounter it. What is the main scale reading? That's 3.1 centimeters plus least count is 0.01 centimeters into vernier scale division is 4, fourth division, vernier scale division. VSR, vernier scale reading. So if you just simplify it, you get 3.1 plus 0.04, and hence the answer is 3.14 centimeters. That's 3.14 centimeters. Second option is correct. Yeah. So let us talk about the next one. Our next model is, in the earlier one, I hope you remember that we got one division of the main scale, but interestingly, the mentioned division was on the right. Okay. The vernier 0 was on the left, but the main scale reading is that division of the main scale which is supposed to be on the left of the 0 of vernier scale. Alright, so that was the tricky part in this question. If you notice here, the question is a bit different model in which, but a easier one in comparison to the last, because they are giving you both the divisions. So see, the diameter of a cylinder is measured using vernier calipers. The diameter of cylinder is measured using vernier calipers with no zero error. So first important concern is that there is no zero error. It is found that the zero of the vernier scale lies between 1.10 centimeter and 5.10 centimeters and 5.15 centimeter of the main scale. So if you consider your main scale, then on your main scale, one division is 5.10 centimeters, another division is 5.15 centimeters, and from here, the zero of the vernier scale, lies in between them. So from here, from this situation, we can retrieve two information. First of all, main scale reading, that division of the main scale that lies left to the zero of the vernier scale. So it is going to be your main scale reading, MSR, main scale reading. Another thing is the difference between two consecutive divisions, which is also basically here it is least count on main scale. I repeat, this is not the least count of vernier caliper. This is the least count of main scale. Least count of main scale, or can also be called as 1 MSD, main scale division. And that is equivalent to the gap between them. The gap between them is 0.05 centimeters. The gap between them is 0.05 centimeters. Alright. Now the situation is sorted. What else, sir? What else is given? The vernier scale has 50 divisions equivalent to 2.45 centimeters. Also, 50 vernier scale division is 2.45 centimeters. 2.45 centimeters, that means 1 VSD will correspond to 2.45 by 50 centimeters. So I guess I'll get it as 0.49 centimeters. 0.49 centimeters. So least count of vernier caliper is equal to 1 MSD minus 1 VSD. 1 MSD minus 1 VSD. So one main scale division is 0.05 centimeters. And I guess this will be 0.049. Please do the calculation. 0.049 centimeters. So the difference between them is 0.001 centimeters. The difference is 0.001 centimeter. Now they are telling you the 24th division of the vernier scale coincides with one of the main scale division. The diameter of the cylinder is, again I'll start the same. I'll write diameter, reading of the diameter, external diameter, internal diameter, depth. These are the three applications of vernier caliper. That is main scale reading plus least count into vernier scale reading minus zero error. The first line of the question says no zero error, take it to be 0. Main scale reading is, we have identified that reading which is left to the vernier scale. Don't forget that's in centimeters. Least count is 0.001 centimeters and it is 24th division mentioned in the second last line. Okay. So it is 0.24. If you add them up, you are getting the answer as 5.124 centimeters. 5.124 centimeters. Hence option D is absolutely correct. Alright. I hope you understood all the phases of the questions. So greater the size of the problem, more descriptive more details are actually provided to you. So it's not going to be tricky. Just read the problem in the installments and try to deal with it accordingly. Have a look for 1 minute, then we will proceed. Have a look of each and every minor details here. You can map the language of the problem with every phase First line, what information? Second line, what information? Like that. All right. Let's go to the last model of vernier calipers. What is so different in this model? That's also pretty interesting. Easy hai, but I have seen students making some sort of silly mistake in that. So let us see. So the last model says the main scale of a vernier caliper is calibrated in mm. Calibrated in mm means main scale reading. One main scale division. One main scale division is 1 mm. Okay. And 19 divisions of main scale are equal in length to 20. 19 main scale division are equivalent to 20 vernier scale division. From these two, I believe that we can calculate the least count of vernier calipers. So we can say least count of vernier caliper will be 1 MSD minus 1 VSD. So that can be written as 1 MSD. I hope you can now do it orally here. It is 19 by 20 MSD. So it is 1 by 20 of the main scale division, which means that is 1 by 20 of main scale division is 1 mm. 1 mm. So if it is 1 by 2, that's 0.5. It is 1 by 20, that is 0.05 mm. 0.05 mm, or if the situation demands, because options are not given this time, 0.005 centimeters. 0.005 centimeters, depending upon the requirement. What else? In measuring the diameter of a cylinder by this instrument, the main scale reads 35 divisions. So main scale reading is 35 divisions. 35 divisions, but the answer should be in measurement. So that is 35 into 1 mm. So that is 35 mm or 3.5 centimeters. Fine. And fourth division of vernier scale coincides with the main scale, and VSR is equal to 4. 4. Zero error is not given. So zero error can be taken as 0. Okay, not given. Say zero error is equal to 0, because that's not given and no such detail of coinciding 0, jaws in contact, anything, nothing has been given like that. So basically, ultimately the question is find the radius of the cylinder. That's what I want you to focus on, that people get too indulged in the operation of the vernier caliper that they just directly find the reading, and from the very first moment, the initial stage of the lecture, I am telling you that reading is of the diameter. Reading is of the diameter. So let's not do this kind of silly mistake. So reading diameter stands for MSR plus least count into VSR minus 0 error, not given. So 0 error can be taken as 0. What else, sir? Main scale reading is given to you as 3.5, that's in centimeters, plus least count in centimeters is 0.005, 0.005, and VSR, vernier scale reading is 4. Okay, so what you got is 3.5 centimeters plus 0.02 centimeters, 0.02 centimeters. So that is 3.52 centimeters. So if they ask us the radius, so radius R is equal to diameter by 2. So you just have to do 3.52 centimeters by 2. Alright. So how much you got? Oh, the simple calculation you can do. So finally, I hope you are clear with this model. The tricky part of this model is people get stuck here, and generally the option 1 is exactly this. So in rush, in the examination pressure, we tick mark. Be careful. You don't have to get the reading of the you don't have to get the actual reading, because actual reading can either read external diameter, internal diameter, or maybe the depth of container. Alright, but the required was radius. You can have a look. Try again to map up the minor details along with the question. I hope you have understood the vernier caliper. Let's hope that in exam this year we get a problem from vernier calipers, and I'm sure if that comes, you are going to score it positively and accurately. All the best.